Simple explanation of neural network without using any heavy mathematics in such a way that even high school student can understand it easily. Let's say there is a group of students who have never seen koala in their life. Koala is a nice cute looking animal from Australia, and these students are very naive and they have never seen this animal, and our job is to train this group of students so that you give them an image and they will be able to tell you whether this image has koala or not. You can make this a teamwork and give individual responsibility to each of these students, such as Mike can work on detecting only eyes, Mohan can work on detecting only nose. So each of these students are working on detecting a specific part of koala's body from an image. The way they give their decision is by using a score of 0 to 1, where 0 means this is definitely not koala's eyes, 0.5 means yeah, it looks like koala's eyes, I'm not sure, maybe 50-50, 1 means it is definitely koala's eyes. Once these students are trained, and we will look into how exactly you can train them, that is also very important part of neural network, but that will cover in the later part of the video. But for now, just assume that these students are trained to detect specific part of koala's body. So Mike has become now expert koala eye detector. Similarly, Mohan is an expert koala nose detector. When you give them an image of a lion, Mike will say the decision is 0.03 because the eyes, they are like round eyeballs, but they don't look like koala's eyes, so 0.03. Similarly, for nose, he can just give some score. And if the score is more than 0.5, we'll say, yeah, those are koala's eyes or nose. You can extend this collaboration further and make Shakib an ear detection expert. And then these three students can go to Serena, and Serena can work on deciding if the image has koala's face or not. So once Mike, Mohan and Sakib says that this image has koala's eyes, nose and ears, Serena can use their work to figure out if the image has koala's face or not. And she can use a formula like this, because if you look at koala, the nose in koala is very prominent. Koala's nose are very different than other animals. So if there is a prominent feature, then you can give that more weightage. And Serena can derive this formula for detecting the face, and based on the scores that Mike, Mohan and Sakib gives, she will simply use this formula and tell you whether the image has koala's face or not. For example, in this particular case, I have given sample scores by each individual person, and Serena computes the face score to be 0.79. So if anything is more than 0.5, it means it is koala's face. Similarly, if there is lion's image, you will see that based on the score, the face score will be 0.15, which means it is remotely looking like koala's face here. You can now use rest of the group where they individually, for example, Jyoti can detect legs and Chen can detect tail, and they can tell their decision to Nidhi, whose job is to say whether the image has koala's body or not. And finally, Serena and Nidhi will go to Sergey, who will give the final answer. And he will also use some kind of formula here. I'm giving more weightage to face because when we are working on face detection, either humans or animals, when we are working on detecting whether it has humans or which animal, we give more weightage to face. So now this group is doing this awesome teamwork and telling you whether the given image is koala's image or not. This is nothing but a neural network. Each individual person here are individual neurons, and they are working on a specific subtask, and they pass the result of their subtask to the next group. So Serena and Nidhi are actually, in terms of neural network, they are a hidden layer. Mike, Mohan, etc., they are forming the input or the first layer, and Sergey is the output or the last layer. So this is a neural network. It's a trained neural network. Now the